All right. Thank you very much. Thank you, and good evening, everyone. And I welcome you all back to this session. Right. Okay. All right. So let's get started. So in the last session, we have started discussing about statistics hypothesis. All right. So there we discussed what is hypothesis, and just a second, guys, just a second. Sorry. Okay. Sorry about that. So we started discussing about hypothesis and types of hypothesis and different types of tests we are going to discuss going forward. A one-tail test and a two-tail test. Theoretically, we discussed how we can conduct any test, right? So yes, so let's begin our discussion with a simple problem statement using uh, you know statistics, how we can solve a problem, right? So if you look into this problem statement, basically there is some uh, data here, right? Some data means the average and things like that. Let's understand with a problem statement what we are going to test and what is the problem here, right? A car manufacturing company claims that any car company, let's Honda or maybe Hyundai, any, they claim that all their cars, mileage of all their cars is 25 kilometer per liter, right? All the cars. They are talking about when they say all the cars, right? So means they have manufactured maybe tons and tons of cars, right? Lakhs together cars. So which means that they're talking about population, right? Population. So average is 25, right? Average means a mean 25 here. The population standard deviation is noun, right? Standard deviation is noun from the past experience. It is 1.5 kmpl, right? Let's say we in general we talk, right? Hey, it will give around a 25 kilometer uh, per liter, but plus or minus 1.5, right? 1 point. That's how you need to understand this, right? So that is population standard deviation. So now one car company, car rental company, right? They wanted to start a new rental company, and for that they need thousands and thousands of cars. They want to set up a rental company in multiple cities. Definitely, it requires thousands and thousands of cars, and they are looking for different companies, and they have approached this, let's say Honda company. They approached these guys, and they checked the average and the standard deviation, and now car company, rental company wanted to test it, right? They are claiming 25 kilometer per liter. No one can blindly trust, right? 1000, let's assume 1000 cars means multiply by, let's say, 15 lakhs on an average. Think about it, right? So they are going to invest crores together money. So they can't just blindly buy the cars, right? They wanted to test it. Hey, you are claiming this much, so we wanted to test. At the same time, they cannot test thousands of cars, right? Time consuming. We need a manpower. So what they did, a car rental representative. So what he did randomly, he picked 30 cars randomly, right? Different variants, and randomly he picked 30 cars. So 30 cars can be tested. It can be, you can drive 30 cars, right? So number of cars, samples is 30. So they drove 30 cars, and every first car, what is the average? Let's say 24.2. Second car, 26. Third car, 22.5. Likewise, 30 cars they drove, and they have recorded the mileage of each car, and they took a average, right? So the average mileage of the sample is what? 30. Turned out to be 24.2 kmpl. Now what they should do? Should they buy Honda cars, or they should walk away and approach some other company? So the decision needs to be made here. The problem, the objective is whether they can go ahead with 1,000 cars with a Honda company, or they can approach some others, buy or not buy. So that is the idea here. So the null hypothesis, whenever they talk about a population, right? They're talking about a population average. So usually whenever we go to any showroom, right? Whatever they say, right? We kind of trust them. That is a null hypothesis. That is assume. Whatever they claim, we assume that it is correct. That is null hypothesis, right? What is null hypothesis in our case? Equal or greater than 25 kmpl. So we are going to test it. Means we are going to conduct an alternative hypothesis test. So alternative hypothesis is less than 25, opposite of null hypothesis. But we have a standard deviation, right? They already said that, okay, plus or minus 1.5. So keeping that in mind, keeping all this data in mind, we wanted to test it and we'll decide what we should do, right? So the same data, everything I have already assigned here to different variables, a mean, sample mean, standard deviation, samples. Where is that? Here, right? So let's see how we can conduct a test here. So I will show you two ways. One, manual way, manually how we can do that, and through statistics. So whenever I say statistics, behind the scene, how it works, right? So that we will check, right? When I say manual, it is basically behind the scene. Okay. So it uses a Z score, Z statistics. So it is a simple formula, right? It uses a simple formula. We have a sample mean minus mean. Sample mean minus mean divided by standard deviation divided by NP dot square root. So it means that X bar mu divided by square root of En. This is standard deviation. So usually Z statistics is X minus mu divided by standard deviation. Okay, this is what is the Z statistics when you have population standard deviation. Fine, we have a population standard deviation, but we are testing those samples. Those samples, what is samples? 30. 30 is what? Samples. We don't have a sample standard deviation. See, population average is 25 kilometers. per liter. Population standard deviation is 1.5. We have a sample mean, sample average. This is a population average. This is sample average. For this sample average, we don't have a standard deviation. So how do we get that standard deviation? Right? So that's why what we are going to do, we are going to use standard deviation divided by square root of En. This is how we will get the sample standard deviation. So we got a 24.2, right? Sample mean. So plus or minus what? Plus or minus what? We don't know. That is not given because we draw this and got this number. So how do we get this plus or minus? That is nothing but sample standard deviation. So this is what we have put together here. So we will get a Z score here, minus 2.92, right? So this is Z score. So now the question is, how does this number determines whether the car rental company should buy or should not buy the cars? So for that, we are going to head towards this Z table. You can check in the Google z-table.com. You will get this table. Where is that table? Table. Okay, let's find that table. Okay. z-table.com. Okay. So you will find this table. Where is that guy? This guy. Okay. So now minus 2.92. Let me write separate in a white space here. Minus 2.92. So I can write this 2.92 like 2.9 0.02. This is how I can write. So this is going to be 2.92, right? That is minus 2.9. So if I add this, I will get 2.9. Come on. I don't want to subscribe. Fine. So now we are going to look for this number. I mean, the number we are going to look using this 2.92. This is a Z score. So minus, this is minus 2.9, right? So where we have minus 2.9, this is minus 2.9. Okay, this one, right? Horizontal, vertical, we'll look for 2.9, and here horizontal, right? So dot 02, right? Where they are going to converge, they are going to converge over here, 0.0018. So what is this value? So this value, we call it as a p-value. What is p-value? We will discuss that, how this is going to help us. So if we use the statistics behind the scene, this is what is going to happen, right? Everything is already set. So how it is going to find out this p-value? Through this Z table. So this is a manual. This is how it works behind the scene. But we don't need to do all this. We are going to use statistics, all right? So I think this should be, we will do one thing, we'll just keep this p-value, all right? So using a statistics, what we can do, first and foremost, we need to import stats. So import scipy.stats. Scipy is a scientific Python dot stats. Right? We'll import NumPy also because to take a square root we need. Fine. So statistics, this st dot norm. Norm means normally distribution, normal distribution. Why we are saying a normal distribution? So in the statistics, in the inferential statistics, right? So there are two types: descriptive and inferential statistics. I hope that has been discussed during statistics class. In the inferential statistics, we assume that, listen to this carefully, we assume that if sample size is greater than or equal to 30, we assume that data is distributed normally. Data is distributed normally. So in our case, sample size is 30. So we are going to assume that it is normally distributed. That's why we're writing norm dot CDF, cumulative density function. There is a function called CDF, cumulative density function. We are going to use that. So this guy, CDF in the statistics, this function is going to do all this magic. Whatever we have discussed, it is going to do all that magic. So what we need to give, we just need to give the sample mean, that is X bar sample mean, right? Let's write the sample mean only, otherwise you'll get confused. Sample mean, comma, overall mean, population mean, comma, standard deviation, right? We can, the parameters are location and scale, otherwise directly you can write. So standard deviation divided by numpy dot square root, right? That is basically square root of n, right? We don't have a symbol here. We have to use a numpy dot square root. So we just need to give all this data, whatever we have here. So it is going to give us p-value. So let's go ahead and run this. So it is giving exactly same like this, right? So if you round this off 0.0018 only, right? You can, if you round this, you'll get 0.0018, right? So this is what we got using a table, and through statistics also we got the same number. So what is this? This is called a p-value or probability value. So what this value indicates? This value determines if the result is statistically significant or not. Means, is it sufficient to prove? What to prove? Now let's talk about it. Right? Yes. So now, so we have this number, which is called a p-value. The guideline says that, the guideline says that if p-value, whatever the value we get, right? If the p-value is less than 0.05, this 0.05 we call it as a alpha level. Alpha level. If p-value is less than 0.05, then we reject null hypothesis. What is null hypothesis here? Null hypothesis is all our cars will give greater than or equal to 25 kmpl. So this is the null hypothesis. based on the p-value. What is p-value? 0.0018. Is it less than 0.05? Yes. Then what we'll do? We are going to reject this null hypothesis. Rejecting null hypothesis means that the claim is wrong. We are not going to buy cars from that Honda company. So the decision is being made. What if it is greater than 0.05? We failed to reject the null hypothesis. See, you need to understand a very thin line here. See, why are we conducting a test? See, whenever you want to test any product or item, right, you are testing it. Why you are testing? You wanted to prove whatever the shopkeeper is saying, it is wrong. That's why we test. So when you fail to reject, see, if something doesn't work, you will reject the offer. You will say that, okay, I don't want to buy. You will reject his claim, whatever he's claiming about that phone or TV, anything. So when you fail, when you are not able to uh, uh, prove that he is wrong, then basically what happens? You failed to reject the null hypothesis. So we don't say that we accept the null hypothesis. Technically, we say we failed to reject null hypothesis. We tried to reject, but we failed. When p-value is greater than alpha value, alpha level, that is 0.05. So in our case, p-value is less than alpha value, that is 0.05. So the conclusion is that yes, we will not buy the cars. So this is the idea here. Statistically, how we'll be able to solve the problem using uh, by checking this p-value and comparing with the alpha level. So when what is this 0.05? Is it all the time same? Not actually. But actually, what is this 0.05? Fine, there is a number, but what exactly is that? So it means that, see, let's understand this way. Okay, I'm going to enable the chat. First, listen to this question. If, okay, let's say a student has come, he completed the course, and his technical round is over, and his HR round is pending, which is going to happen tomorrow. And you call me and ask that, okay, sir, this is all what happened. We completed all the rounds, technical, this discussion, that discussion, written test. Only salary discussion is pending, which is going to happen tomorrow. So how much I can expect, right? So let's say you are saying I have 2 years of experience, right? And how much salary I can expect. So you are asking me, right? So now I will say that you will get 6 lakh per annum. Okay. Based on my past experience, I will say 6 lakh per annum you're supposed to get. HR interview got over and you got 5 lakh 75 or 5 lakh 7 lakh 75 lakh per annum. Okay. This is the actual salary. HR interview over and you were offered 5.75. Now my question is that what do you say about my prediction? I predicted you will get 66 lakh per annum, but actually you got 5.75. So what do you think about it? So how do you rate my prediction? Is good, bad, average, or how are we going to rate my prediction? I'm asking you, I have enabled the chat. right? So most of you are saying good, very close, average, but nobody said bad, 4 out of 5, right? See, the answer is lying in your response only. See, you are saying still good. Why are you saying still good? Even though I made a mistake here. I made a mistake of 0.25 lakh, but still you are saying it is very close to the prediction, right? So the mistake I did, right, 0.25, very interesting. The 0.25 lakh per annum mistake I did. So which means that you allowed me to make that mistake. Hey, that much mistake is fine. It is acceptable. You know what I'm saying? That is acceptable. 0.25 is acceptable. Fine. So that is what this 0.05. So we are allowing, okay, you are going to find out some value. So, but if that value is less than 5%, this 0.05 is nothing but what? 5% mistake. Out of 100, you are allowed to make 5% mistake. That is what you have given me, right? So that is what 0.05. If somebody says that with alpha level 10, 0.1 means he is allowed to make up to 10% mistake. So if it is not given, then it is 5%. That is nothing but 0.05. Is that clear? How to interpret this? Okay. So good. So that is basically what. So we even with that 5% alpha, still you are not able to get the correct. That's why we are rejecting it, rejecting the null hypothesis. Fine. We'll see a couple more such examples. And before that, we need to understand something important, that is type 1 and type 2 errors, right? We have a few more tests need to be conducted, right? We are going to test, work on many problem statements here, right? In case if you have a little bit of a confusion here, I will make sure that you will understand p-value, rejection, things like that. Fine. So now let's understand in a real life, right? See, whenever you take opinion from someone for any reason, X, Y, Z, let's say you wanted to enroll for data science program, okay? And for sure, you would have taken opinion from your friends, family, or your colleagues, or whoever, right? So they have given opinion. Either yes, go ahead with this program, or no, right? Otherwise, let's do one thing. Let's forget about this data science program. I will make it very simple. Let's say you wanted to invest 1 crore rupees in any business. You don't just go ahead and start the business, right? You will do some research. You will take a lot of, you will see, you will seek suggestion from others, right? Let's say you trust someone who is very good in the business, and you approach that guy, and you ask that person that, hey, I wanted to start XYZ business. Shall I start the business or not? Right? So he will either say yes or no. Correct? Yes or no. So whenever he say yes, right, in real life, right, only two outcomes, either yes or no. Whenever he say yes, it doesn't mean that he is always correct. So when he say yes, you are going to invest 1 crore rupees, so that business will be success or it will fail. So there is a chance that you have a success and you have a fail. When he say yes. Similarly, whenever they say no, again there are two things, either success or a fail. So now let's talk about a type 1 error, right? When he say yes, you invest 1 crore rupees. If you are succeeded, that's great. Wonderful. If you fail, means he asked you to invest, but business did not go well. But business did not go well. Even though the expert says go ahead and invest, but it did not go well. So that is one mistake. That mistake is type 1 error. Right? So I'll come to this type 1, type 2. First, let's understand where and all we can make a mistake. So this is one mistake, correct? And another case is when he say no, hey, don't invest in this business, you don't get any profit here, right? So if you don't invest, then you are succeeded. Fine, great. You did not invest it, your money is with you, fine. Then you think, you think that okay, he's saying no. Let me take a chance and invest. You invested again, right? But the money did not come back. There also you failed. Means when he say no, there are two chances whether it will work or no. When he say yes, either it will work or no. So there are two types of errors, one error and another error. So those are type 1 and type 2 error. So let's come back to our car example to understand much better. Type 1 error means if H naught is true and you reject null hypothesis. If H naught is true and you reject null hypothesis. Let's talk about this case. So he is saying yes. Hey, you invest, you will get a success. But you think that, okay, I will not invest. I will reject your opinion. But actually, if you invested, you would have got success, you would have made some profit. But you rejected this. Means that is a mistake. So that is a type 1 error. In car example, if average car mileage is really giving 25 kmpl or maybe more than that, but rental agency rejects it. Hey, I don't want cars, although it is giving more than 25 kilometer per liter. And if he reject, then it is a type 1 error. So type 2 error, if H naught is false, means car mileage is really less than 25 kmpl after driving and everything, but still rental agency buying the cars. When you see that it is not giving 25 kmpl, but still you are going ahead and buying the cars, in future you'll get into loss. So you failed to reject. You should have rejected, but you failed to reject H naught. It is type 2 error. So whenever you take opinion, either the mistakes are either type 1 or type 2 error in real life also. Okay? Statistically, we summarize in this manner, type 1 and type 2. So why it is very important to understand? Because in machine learning, we are going to discuss this, right? So that time again, I'm going to talk about this type 1 and type 2 errors. So here the theory is the idea of how to interpret this type 1 and type 2 error. Fine. So let's move on. And so statistics is all about concepts, right? In between, I am trying to come up with some simple problem statements so that you all get used to these statistical terms. Then only you'll be able to remember this. If I just talk about only theory, it is difficult to store those terms in your mind, right? So at the same time, we'll try to understand how statistics works. I mean, statistical, the hypothesis testing, to be specific. Fine. Now let's talk about statistical tools, right? There are various statistical tools. The most important are t-test, or it is also called as student's t-test, right? ANOVA test, chi-square test. There are other tests which are not that popular. The most commonly used statistical tools are these three. So every tool will discuss with a problem statement. So in the t-test also, let's start with the t-test. In t-test, we have one sample t-test, two sample t-test. So we'll begin with one sample t-test, right? One sample t-test means is used to determine whether the mean of sample is significantly different from the known mean. So if you don't understand this, don't worry, I will explain in a best possible way with the numbers, with the data set. So for that, what we will do, we will take one data set. It is available in the GitHub repository, hypothesis t-test. This is a data here. This data set is about a student's score, marks, right? Gender is also there. 0 means it is, let's say, a male, 1 means a female, right? So we have maths 1 score, maths 2 score. So this is student's score data set. Now, one teacher checked all the students' marks, the whole data she checked, including gender, maths 1, maths 2, SST, everything. And she kind of felt that, okay, hey, these students are actually intelligent. If I give more training, if I take more classes, if I give more ideas, if I conduct extra classes to these kind of students, they will score greater than 60 marks in the competitive exams. That is what teacher thinks based on her past experience. So she thinks they will get more than 60 marks in the exams. So now here the null hypothesis is the average score students will get greater than or equal to 60 marks. That is null hypothesis. But she wanted to conduct a test. Overall, it looks good. That's what she thought. But she really wanted to conduct a test, whether I should go ahead and train these students, conduct extra classes or not. I want to make a decision. So she wanted to conduct alternative hypothesis is will not get, they will get a less than 60 marks, right? So we are going to conduct that test. We will start with a one sample t-test. So first of all, alpha level is not given. So by default, it is 0.05 or a 5%. Just now we spoke about it. So sample mean, let's say one sample t-test. So we'll take a maths 1 score, right? The average maths score is 52.645, right? So we will say sample average, that is 52.645. One sample, only one column we are taking math 1. The average is 52.645. So what is the average she is expecting students will score, right? So average is 60. So we have alpha level, we have average, maths 1 score. This is the expected average score. So we'll take this data and we conduct this one sample t-test. One sample t-test, all the sample t-tests are very simple. So what we'll do, we'll import statistics, scipy.stats as a st.t-test. Which test we are conducting? T-test underscore one sample t-test, right? One sample. So for that we need a data maths 1, right? In this data set, maths 1, comma, average score, that is 60. That is what she expected. But in overall average of maths 1 is 52.64. Here I am keeping this just to compare the expected and the actual average. So let's go ahead and run this. Okay, sorry, I did not assign this value. So here we got p-value. See, we get a statistics score also, that is -11. We are not interested in this. Why we are not interested in this? It is similar to Z score. Similar to Z score, right? So here we have a statistic score. So how it works behind the scene? Same. So 11. So there'll be a table. Again, it will be checked. So you will get a value somewhere in that table based on the statistic score. That's why we are not interested in a Z score, sorry, statistic score. We are interested in only p-value. P-value is 1.33. But if you look into this, right, it is e raised to -22, means 0.000021 times, then 133. So this is basically our actual p-value. Now, is this p-value less than alpha? Is it less than 0.05? Yes, it is. It is less than 0.05. Now I want to hear from you guys. Okay, sorry. So what is the conclusion here? I have enabled the chart. What is the conclusion? By looking into this p-value, comparing with the alpha value, what is the conclusion? Conclusion of one sample t-test. Great. All are correct answers. Everyone. Everyone. We reject the null hypothesis. What was the null hypothesis? Null hypothesis was this type of students will score greater than or equal to 60 marks. But based on the p-value, we will say that no, these students will not score greater than 60 marks. That is when we conduct one sample T test. Does that mean that a teacher assessed the students wrongly? Was her past experience is that worst that she cannot judge the students' marks and she cannot judge the students? We don't know. So what we will do now, we'll conduct a two sample T test. She checked only, we took a maths one only. We did not take a gender, we did not take a maths two score, right? So, but teacher has seen the overall data, maths one, maths two, gender, everything, right? So now we will conduct two sample T test. Just a second. We'll conduct a two sample T test, then we'll see whether she is right or wrong. So in order to conduct this two sample T test, we have again independent T test, independent sample and paired sample. So independent means here we can take a gender. You can take a program also. There is a program column. Let's see how things will work here. So this is our data set, okay? Value counts of gender is, let's say male 109, female 91 students, right? So we are going to subset the data. We'll take a maths one score, but gender wise, right? So gender one means, let's say male students, maths one score. Male students, maths one score, right? I'm just trying to show how we can subset it. We'll use this down the line. These are all male students marks only. So independent means male and female, independent. So how are we going to test this? So we already imported stats, scipy.stats dot, which test we are conducting? T test find underscore, which sample, which sample T test? Independent sample T test, IND. So then in the parenthesis, this one male students, comma, female students, maths one score. We are going to separate, subset them and give it because individually, male, female, right? So it is going to produce again a statistics score as well as a t-test. So we are going to collect in two different variables. You can directly print it just how we did it. So we are interested only in p-value, right? We'll collect in two different variables and we'll just print whatever value we wanted. Run this. We are interested only in a p-value. P-value is 0.68. 0.68. Is it less than 0.05? No, it is not less than 0.05 or alpha level, which means that what? Yes, keep it coming. Yes, It's not prediction is correct. See, basically, we will say that we failed to reject the null hypothesis. We failed to reject the null hypothesis. How can you forget? We just discussed few minutes ago, not last week or something. Maybe 5-10 minutes ago, we failed to reject the null hypothesis. Don't forget that. Some students responded correctly. So we failed to reject the null hypothesis, which also means that yes, teacher can continue to train those students. Means they will get more than 60 marks. All right. So that is what it is. Subsetting, someone is asking subset. So this is a pandas, guys, right? Go back to pandas. We have done that, did we? We worked on a subsetting, how to subset the data. That's why I keep saying that you have to keep yourself updated every lecture, right? So here we are adding a condition. This is the condition. Condition is what? Select this column from this data set, check whether it is equal to 1, right? Whenever it is equal to 1, select the data from this data set. Then take their maths 1 marks and head method. Here I'm just showing you, right? Here you don't need head method. So only maths 1 score of male students will be selected. Only maths score of girl students, maths will be, marks will be selected. Fine. One of the student asked this subset. So guys, please keep yourself updated, okay? Because very soon we are going to start machine learning, right? At that time, if you struck with the basic things, right, it is going to be difficult to understand upcoming classes, right? You have a time, so please revise everything. You have all the recorded, you know, live recorded videos are there. Keep, checking, revise. All right. Anyway, that is independent sample. Then we have another paired sample, right? So paired sample is, pair means what? Two, right? So here maths 1, maths 2. So we are going to conduct paired sample t-test, st.t-test underscore. So paired sample, we don't write a pair, it is REL, relational, right? So maths 1, comma, maths 2 marks. Say it happens, right? I'm sure you would have experienced this during academics and all, right? What happens? Uh, the first test will come as soon as we start the semester or the year, right? We don't even get settled in the new semester or a year. Immediately first test will come. Most of the time, we score less in the first test. Then after getting the first test marks, we realize that, oh, we have to study, right? We are getting less marks. So next time in the second test, we'll get a good marks most of the time. That is the trend, right? So a teacher might have seen that also, isn't it? She might have seen that trend in the first test 40. If I just quickly show you this, maths 1, you see 41. Maths 2 increased, maths 2 increased, maths 2 increased. One student's marks is decreased, but fine. Overall, I'm talking about, right? Teacher might have checked that also. Let's test relational, right? So run this and check the p-value. P-value is greater than alpha. So again, we fail to reject the null hypothesis, which also means that she can continue to conduct a special class for those students and help them to achieve or get more than 60 marks. So this is t-test. It is also called as students t-test. There is a story behind this. In case if you are interested, you can check in YouTube or somewhere why t-test is called students t-test. Some short story is there. Okay. If you are interested, you can check it. Otherwise, it is not that important to know. But yes, uh, these two names, both are same here. Students t-test and simple t-test. Okay. All right. So let me check with you. I just want to take your feedback so far about statistics. Okay. This is for my recording purpose. I just want to know what you thought about statistics and what you are feeling. This is for my personal record purpose, right? So whatever you thought about the statistics, whether it's tough or easy, and compared to that, based on what we discussed in the last 1 hour, so what you feel? Is it okay, easy, tough? You need to revise, whatever your response here. Give your honest opinion. Don't say that, okay, sir is asking, I have to give good response. Not like that. You can say that, okay, it's tough. If it is tough, it is tough. Yes, we are going to see more examples. Yes, of course, you need to remember and revise. So you don't need to remember actually. If you practice this, you don't need to remember. Automatically, it will store. So as I said in the beginning itself, I said that we don't provide Jupyter notebooks, the file. It is not a secret recipe, guys. So you keep this video right hand side and left hand side. You can open Jupyter notebook and listen one more time. So that way you are going to revise one more time and at the same time you can practice. It is double benefit. If I give a Jupyter notebook, you will execute my code, you will not gain anything. If you still want it, if I would be you, what I will do, I will pause once when I'm revising, right? I will pause, I will take a screenshot. That also we can do. If you really want a PDF, notes of this PDF, right? Many students are doing that. In case if you don't know, I'm just giving an idea. Fine. Okay. Let's take a small break here. All right. So we will talk about the next tests. All right. All right. All right. So, see, what happened until now is in the t-test, right? So we have one sample t-test, two sample t-test. So what there are three samples? What if there are three groups? So can we do all types of testing using a t-test only? No. If more and more groups or samples wanted to test, then we have only options only for two samples, right? If the samples are more, let's say maths 3, maths 4, or a program, right? If there are only two programs, 1 and 2, that is fine. If there are more than two groups, more than two programs. So if there are more number of variables, more number of groups, then we can't test using a t-test. We can't conduct a hypothesis testing using t-test. Then how are we going to conduct the test? There comes ANOVA test. ANOVA test. See what happens if there are more samples, more groups, right? So how much we are allowing to make a mistake? 5%. That is 0.05. So let's take one example. So earlier I said 2 years of experience salary prediction, right? So based on only 2 years, only experience, I predicted salary 6 lakh per annum. Only one variable, that is experience. Now you are going to add age, then skill. This 2 years is what? Is it a data science, or is it a Tableau, or is it a C, a Java, SAS, SAP, right? So that is skill set. Age, then a city, Bangalore. Here we have a data science. Here we have a Power BI. Different age, different experience, age, different experience, different city. So we are adding more and more inputs. So that time my salary prediction will also change. That time I will make more mistakes. The range of mistake will increase because there are more inputs. But we can't allow more than 5%. If more data, if more variables, so the margin also, the error margin also needs to be increased from this much to this much, but we can't afford that. We want to keep only 5%. So that's why ANOVA test will comes into picture, with which we will keep only 5% margin, that is 0.05. Still we'll be able to deal with the problems. So yes, ANOVA test, that is nothing but analysis of variance. ANOVA means analysis of variance. All right. So let's see some assumptions here. Very interesting. Okay. Assumptions are basically usually null hypothesis is that all means are equal. I will practically I will show. Okay. Just remember these words. All means are equal. That is typically null hypothesis. Independent variables are categorical. Dependent variables are continuous. Right. Fine. With the ANOVA, see in the first test, right, we try to find a Z score. Then later in the t-test, we got a statistic score. So in the ANOVA, we will get a F score. Through F score, we will get the P value. So how to find this and all, we will see. This is a formula. I mean, just an idea here. But we will conduct a test, then we'll talk about it, right? Some assumptions. So in ANOVA, there are various types of test. One-way test, one-way ANOVA, two-way ANOVA. So what exactly one-way ANOVA? So I will give a simple example here. So comparing the effect of different teaching methods on students, on student exam scores. One-way ANOVA means, say I am teaching, okay, so my teaching methods are different. Some other person teaching method will be different. So when I teach, how many marks you will get? Same student. Okay, student is not going to change. Only that student. Let's say that student. I am teaching and will conduct exam. So he will get some score. Other teacher teaches some subject and will conduct the exam and check the score. Means on the same student, two different teaching methods. Comparing the effect of different teaching methods. That is one-way ANOVA. So it means we are going to determine whether student is not understanding or student has a problem or teaching is a problem, right? So that is one-way ANOVA. We'll see with the practical. So here we are trying to understand theoretically how to understand this. Then two-way ANOVA. So studying the impact of both gender and treatment type on a patient recovery time. So here, male and female, right? Male and female. So we will treat male and female for some disease, right? Both are having the same disease, X disease, and we are treating both of them, and we'll try to check the recovery time. Who is going to recover faster? What is the recovery time, male and female? Two-way, right? So that is a two-way ANOVA. So when we should use this, it can be this test can be used when there are two independent categorical variables, right? Gender, male and female are two independent categorical variables that may influence the dependent variable. Dependent variable is what? Recovery time, right? So investigates the main effect of each factor and their interaction effect, right? A little technical, but it's nothing. It's just same how that treatment will affect those independent variables, the categories, male and female. So we are going to study that, right? So all these studies will be keep on happening nowadays, right? In the medical industry, everywhere research will be going on, right? So now we know that, okay, if you drink a tea or a milk in the early morning, we know that if you drink a tea or a coffee early in the morning, you will be more active, right? Will active just like that, will become active just like that. If you drink water, right, you will not get active, right? So earlier we did not know, right? Somebody has done the research. They have calculated the time, the reaction time to tea, coffee, milk or water, right? They check the reaction time on different. Then they have come up with this statement that, okay, if you drink tea or a coffee in the morning, you'll quickly get active. That was the research. So similar type of research keep on coming. It's not only about active and all. So which medicine will work faster during a corona and all, right? So they have done lots and lots of research. So they keep coming back with, okay, our medicine is best, it will cure. Our medicine is best, it will cure. So many companies have come, but everyone failed. Most of them were failed. Only few were successful because they come up with the medicines, but when the medical research, the government authorized research team, when they conducted all these tests on different people, that's why you remember they initially they have released vaccine for greater than, I think, more than 60 or whatever the number, right, age people, because they have done the research on that people, that age category people. That's why they released that medicine first. And it is also another reason is that, okay, they wanted to save older people because they are more vulnerable to the disease, right? That is another reason. But the tests were conducted slowly because it took a lot of time to come up with those medicine, because they were keep on testing it on different people. They have asked people voluntarily, you can come and undergo our testing. They gave crores and crores of money to their families. Many people died during that research. That was not exposed, but they voluntarily they have come to take that treatment. They even don't know that whether they are going to survive or not. Right? Some Africans, some South Africans, some Americans, some Indians, they have called many people, thousands and thousands of people. Right? It's just that they don't talk about it because it was voluntarily. And if they expose it that, right, again, human rights, this, that, so many things will comes into a picture. Again, it is going to be a lot of problems. That time we were going through all those crises. It was not that was not the time to firefight and all, right? So everyone was keeping mum because everyone wanted a medicine, the vaccine to come as soon as possible, right? So I'm just giving an idea, right? Anyway, one way ANOVA. So let's take one example, right? ANOVA test for, let's say, fertilizer effectiveness. So let's talk about a scenario here. A botanist is conducting an experiment to compare the growth of plants using three different types of fertilizers, right? I'm sure everyone knows that there are a lot of fertilizer types, right? So let's say fertilizer A, fertilizer B, and fertilizer C. So the experiment involves randomly assigning 30 plants to each fertilizer, right? So fertilizer A, 30 plants, 30 plants, 30 plants, and measuring the height of the plants after a certain period. Okay. So for 30 plants, we used fertilizer A. For other 30 plants, we used fertilizer B. For other 30 plants, fertilizer C. Same type. I mean, let's say wheat, right? Or maybe anything you can think about. But same plants for 30, 30, 30. But the fertilizer is different. So the null hypothesis is all the means are equal, right? Remember that assumption, all means are equal means whatever the fertilizer you use, either A, either B, either C, the growth of all those plants are equal. The average growth is equal. That is the null hypothesis, right? So that is what I was talking about here. Null hypothesis typically is that all means are equal. right? The 30 fertilizers, sorry, 30 plants, and these 30 plants average growth, 30 plants average growth is equal. That is null hypothesis. Alternative is that no, at least one fertilizer type significantly affects plants' growth. That is opposite of null hypothesis. So now we want to conduct a test. Now we wanted to conduct a test. So yes, we are going to import scipy.stats. From scipy.stats, we will import F one way, right? One way ANOVA. F is a F score, right? I was talking about one way. So what we'll do, manually we will create some data here. 30 plants, okay? 1, 2, 3, 4, 5, 6. Likewise, we have 30 plants here, 30 here, 30 plants height. So for all these 30 plants, we used fertilizer A and fertilizer B and fertilizer C. So now, so F one way. So fertilizer A, fertilizer B, fertilizer C. It will give F statistics that it is going to give you F score. We are not interested in that. We want only P value. Right? So we'll check alpha value will keep 0.05 significance level and check if P value is greater than, sorry, less than alpha, then reject the null hypothesis. What is null hypothesis? There is no change. All are equal. Right? So if it is less than alpha, we'll say that there is a significant difference in the plant growth among the fertilizer. Otherwise, we fail to reject null hypothesis. There is no significant difference in plant growths. Means all are same. Doesn't matter which fertilizer you use, it will grow just like that. The growth will be same. So just run that. So reject the null hypothesis. There is a significant difference in plant growth among the fertilizer. Means there is a effect. One of the fertilizer is helping in their growth, plant's growth. Right? See, just try to think in reality, right? You yourself, you are spraying the or you using that fertilizer, right? 30 samples, 30 plants, and you manually will measure it through scale and note down. Similarly, fertilizer B plants growth, you measure it and note down. Just use a simple F1 way. You will be able to understand. It's very interesting. Don't understand this just for the sake of understanding. Try to think in real, in a real. So the big problems can be solved using a simple test. Think about, for instead of fertilizer, think about a vaccine. Think about a person recovery time. 30 people, their recovery time, recovery time, recovery time. Medicine A, medicine B, medicine C. Right? So that is one way ANOVA. Two-way ANOVA. So here we'll take a different scenario. Sorry about that. Two-way ANOVA. So scenario is researchers are conducting a study to determine the effects of diet type. Factor A, low carb, balanced and low fat. This is factor A. Right? Diet type, low carb, balanced, low fat, and exercise level, that is factor B. Sedentary, moderate, active. Exercise, how much exercise you do, right? A sedentary, moderate, or active on weight loss means researchers are conducting a study to determine the effects of a diet type and exercise level on weight loss. It is very simple to understand. Is exercise alone will affect the body, or not or and you can think either way, okay? So will both diet and exercise will impact the body, or only exercise will impact the body, or only diet will impact the body? So how are we going to identify that, right? So for that, what happened, they recruit participants and measure their weight before and after a specified period, right? Before conducting a test, they measured their weight. Let's say some participants, and they started giving low carb, balanced one, low fat, and they asked those people to be more active, moderate active, right, and sedentary, things like that. So how to conduct? So what is the null hypothesis is? You do whatever, man. There is no interaction between diet type and exercise level. They are not related. Diet is different, exercise level is different. They don't impact weight loss. There is no connection between exercise with the body, diet with the body. That is the null hypothesis. There is no difference. What is alternative hypothesis? Yes, there is a effect. There is a connection. There is an interaction between diet type and exercise level. How much do you exercise, and what diet you take? So we are trying to see different combinations here, right? So it is two-way ANOVA. So what we'll do, we'll keep a diet, exercise, and weight loss, right? Let's create this data set first. So this is our data set. So if you have a low carb and a sedentary exercise, your weight loss is 2.3. If you have this combination, this is your weight loss. If this is combination, this is the weight loss, right? We have recorded that. So then we'll import ANOVA here. First, we'll import stats models, right? It is little lengthy, but we don't have other choice here. Stats models.api as SM. Then from stats models.formula.api, we'll import OLS. OLS is nothing but ordinary least square method. Ordinary least square method, OLS. So fine, how are we going to find that? So we'll use the OLS. So we'll give independent variables and dependent variables. Independent variables are diet plus exercise. Dependent variable is weight loss. So this is how we are going to write this, right? Dependent variable, this is a tilde. I'm sure you are aware of this. You'll find it on top left corner in your keyboard. Tilde. So column 1 plus column 2. If you have more columns, plus column 3, and so on. So where can I find these column names? You can find it in this data, that is data frame. We'll say dot fit. Dot fit. So what this dot fit will do, it will analyze the combinations. If this is the combination, this is the weight loss. If this is the combination, this is the weight loss. So all this combinations, all these patterns it will identify, it will learn. Then we will use stats model dot stats dot ANOVA underscore LM. LM means linear model. Then we will pass this object. It learned everything, right? Okay, now we'll use that learning and check the different stats here. So for diet, exercise, we'll understand. So we are interested in p-value. This is F score. We don't want this. P-value, if you use only diet, if you use only diet. So with that, will you be able to reject 0.06 is less than 0.05? No. Or yes, right? So depending on that, you have to take a decision, make a statement. It is less than 0.05, which means that we are going to reject null hypothesis. What is null hypothesis? Hey, there is no relation between diet and weight loss. We'll reject that null hypothesis. We say that, but there is a difference. There is a relation. If you keep diet, if you diet, yes, of course, your weight loss, you'll get a, you will lose weight. So that is with the diet and exercise, 0.03. Is it less than 0.05? Yes. Exercise also plays an important role. Do both will have an effect. So you can just add them 0.06, 0.03. So this is 0.006. Right? Still you will get less than 0.05. You can still reject the null hypothesis. Diet and exercise are directly related to weight loss. It shows other numbers. We are not interested in that. We are more interested in this p value. So that is two-way ANOVA. Let's see one more. Nested ANOVA. So what is the scenario? A study is conducted to assess the effects of different instructors nested within the schools on student exam scores. Students are nested within instructors and instructors are nested within the school. Means it's little confusing. So there are different instructors. Let's say maths. For the maths subject itself, there are different instructors. Right? There are different students. So different instructors will teach those students. So they are basically nested in that school only, within the school, not outside. In the same school, different, same subject instructors. Right? So how it is going to affect? So that is nested now. Will they get confused with the different teachings of the same subject? Or it is going to increase their value, increase their knowledge? See, some in general we talk, right? Hey, that sir is saying something, this sir is saying something, I'm getting confused. Right? We in general will talk. Otherwise, there is other scenario also. Hey, he said some points, very good points. Other trainer said another points. They are both are very good points. So in the exam, you will collaborate both of them and you write. So that time, what happens? Scores will increase. We have two different situations, right? So now we wanted to test that. Is it going to increase, decrease, what? Right? So that is what basically nested ANOVA test. So for that, we have a school instructor exam score, right? So let's go ahead and create a simple data frame here. Fine. So exam score, we are going to use the same OLS method, OLS. So our dependent variable, that is exam score tilde school plus instructor plus school colon instructor. I will explain this. All right. So same ANOVA model, we are going to use ANOVA underscore LM. So let's go ahead and run this and check the result here. Right here, what we did in this case, come on. So here we use the school colon instructor, right? So basically we want to combine this both the p values, right? School instructor, right? It is just added. The added thing is over here. It is not required, but if you want to see together school and instructor, right, in one shot, you can get that also. So here p values are greater than 0.05, right? They are not less than alpha level, right? So in this case, we failed to reject null hypothesis. Right? Null hypothesis is no significant difference. Everything is same. Doesn't matter who teaches, how many instructor teaches, no difference. Which means that in this case, students' mindset are same. It doesn't matter who teach them. They will understand the same thing. Right? You'll have this situation. In our case, the data is like that. Doesn't matter. You can clearly see here. All the numbers are very much similar only. You can clearly see, right? There is no difference. We have school A instructor X 85, school AY 88. Not a big difference. They are 5% in that 5% area only. That much difference only. Right? So there is no significant change. Means all are equal. That is null hypothesis. So based on the result, p-value, we failed to reject. That is what this nested ANOVA model or test. We rarely, I don't say it's rarely, we have such situations, various situations. But in the real-time project and all, right, we don't do this kind of a testing. I'm purposely walking you through all these things so that you get a sense of the statistic. You get an idea what and all can be done in the statistics. So now you are more familiar with this ANOVA, one way, two way, p-value, alpha. If I just use a theoretical, just explain the concept, it is very difficult to memorize all these. So now you are more familiar with, right? So when in future, whenever you are going through some statistics blogs or some notes or anything, right, anywhere in the internet. So whenever they use these words, you will understand immediately, "Hey, this is what it is," right? So you can connect the dots that time. Fine. One last test, the chi-square test. chi-square test. So when we should use a chi-square test, you can call it as a chi-square test also. So we use this to measure the goodness of a fit to a distribution. Let's understand in a layman. Which means that, see, I'll take that same thing like a salary prediction. I was talking about one student salary prediction. There are 20 students and all have reached to HR round. Their offer letter is about to release and they are excited to know their salary, their package, and they are trying to check with everyone, hey, how much I can get, Everyone will have that excitement. So all those 20 students are asking me, okay, what is my package would be, what is my package be? I will predict all those 20 students, 20 candidates salary, right? I will note down in one list, right? Let's say predicted, right? First candidate salary 8 lakh per annum, second candidate salary 7 lakh per annum. Likewise, 20 candidates. All the candidates HR interview got over and they got the actual salary, actual offer letter. In that, they will have some real numbers or the actual numbers. So now we are going to compare this whole thing. The goodness of fit means, so I have predicted how much actual numbers are fitting, goodness of a fit, how close they are to a distribution. This is the data distribution here. My predicted numbers are a data distribution. So how much this data is fitting, that is goodness of fit. How close they are. Are they close or not? How close they are. That is basically to measure that goodness of it. To take another example here, let's say a pizza business, right? So we ask that person that, okay, how much you can expect in next week in terms of sales I'm talking about. So expected is 25,000, 28,000 Monday, Tuesday, Wednesday, and up to Sunday. So this is what he's expecting based on his experience, based on salesperson experience. So that 1 week got over, every day we are noting down the actual sales. These are the actual sales. You can also call it as observe. So how good they are fitting, how observed data is fitting into expected data distribution, right? So it uses a simple formula. So here you can give significance level, alpha level. So this time what we'll do, we'll use a 10% alpha level. That's very simple formula here. Chi-square statistics, summation observed minus expected whole square divided by expected. So what I will do, I will take this data, whatever the data I have here, right? Expected observed, I will keep here, expected observed. So I will apply this formula. What is the formula here? Observed minus expected. Observed minus expected divided by expected. So this is a whole square, right? I'm just going to use a numpy dot square, comma. This is for the Monday and for the Tuesday. Observed minus expected divided by expected. Observed minus expected divided by expected. This one is a square. So likewise, I will do for all the days. Then at the end, I'm going to, this is going to have different numbers, right? So I'm going to sum them, all those numbers. I will get some number. So this is chi-square test statistic score. So how are we going to make use of this? Right here also we have a numbers, sorry, table. So in order to use this chi-square table, right? So you need to know a couple of things. One is alpha level, right? In our case, 0.1, right? They have given this time 0.1 or 10%. So degrees of freedom. So you need to know degrees of freedom. That is a DF, degrees of freedom. What is degrees of freedom? Means how much freedom you have. Like, let's say I'm going to give this number. I will give you 3 boxes. Okay. And I ask you, okay, use 3 numbers so that when you add all those numbers, the total must be 100. Right. So first time, if I ask you to think one number, first number, everyone will think different numbers. Right. Everyone will think different number because you have a freedom. That is freedom number 1. Plus second one. Here also everyone will have different number. Here also you have a freedom. Once you get these 2 numbers, let's say I'm picking a 40 here and a 30 here. These 2 freedom I have. The third one, I don't have a freedom. I don't have freedom. I have to select 30 only. So what is the degrees of freedom here? Only 2. That is total number minus 1. So total, in our case, what is the total events? 7 events, Monday to Sunday. 7 minus 1. So here n is equal to 7. So degrees of freedom is 6 here. That is degrees of freedom. Right? We got this DF and significance level 10. And our test score is 2.58. So these 3 numbers we have. So let's go ahead and check for degrees of freedom. What is the degrees of freedom? 6. Okay. What is the significance level? 0.10. Okay. Right. So what is the value here? 10.645. What we have our test score? 2.58. Right. So we are going to compare this. The number we got from our testing and the number in the chi-square table, right? So as the critical score in the table is what? 10.645, greater than our test score, that right? 2.58. It is greater. So in this case, if critical score, that is a table score, is greater than our test score, we cannot reject the null hypothesis. If it is less, then we'll reject the null hypothesis. Null hypothesis is what? There is no difference, which also means that sales prediction expectation was correct. Means they are almost same. We cannot reject the null hypothesis. Right? Means they are same. Expected and observed almost similar. Understand? Similar, when I say similar, they are not 100% same. We have a significance level 10 here. We are allowing make some mistakes. Even though a little bit of a difference, we still accept it. Right? This is chi-square test. Very simple one. We will use this chi-square test, ANOVA test in the machine learning also. All right. So fine. I have enabled the chat one more time. So is this testing, ANOVA testing and chi-square testing, we discussed different situations. Did those examples helped a little bit to understand the situations now? Did you find it little better than before? So I'm not expecting everyone to understand everything in the first instance. I know many of you are very, very new to the statistics. It's absolutely fine. Even if you understand 40, 50% in the first instance, still you are doing great. Honestly, right? So you have to revise this. You have to revise this. So things be will get clear. The more you revise, things will get more and more clear. All right. So you have a week of time, right? Please revise this because we are going to use these concepts in the machine learning, right? And in the next class, in the next week, we are going to start with machine learning. Machine learning, the core, the main part. So we will utilize, we will leverage all the skills, whatever you have learned so far, starting from Python, NumPy, Pandas, visualization, statistics, SQL. We will utilize everything. On top of that, we will see how to build a model, right? How all these skills will help to build a model. Very, very interesting, right? So before that, I request everyone to revise once. Daily keep 2-3 hours separate. If you are keeping more, then it's really great. So revise this, whichever the concepts you are not clear at, revisit. You can put fast forward and, just listen. You don't need to, if you have practice, that is great. Otherwise, you have to practice, of course. So revise and it will help you only. You just need to help yourself. Okay, I will try best from my side and you have to put effort from your side. Okay. So that's all for this week, guys. And good night, everyone. And I will see you around again next time, next week, same time. Until then, take care and well, have a good night, guys. Bye bye.